Okay, so let's look at some just basic proofs. Like I said before, we're going to be doing a lot of proofs in this course. And again, a proof is really just a logical argument made where you make a statement that you claim is true and then a reason for why it's true. And so what we're going to look at are some theorems. So theorems are mathematical statements that can be proven to be true. And then once we've proven a theorem is true, now we can use that as a justification in a proof. So we're going to just do a couple of really short ones here. And it may kind of seem weird to prove these because some of them I think are just going to be so obvious that it seems like we shouldn't have to prove them. But I want to show you sort of the basic structure of a proof using some of these really short examples. So our first theorem is that if two angles are right angles, then they are congruent. So you're going to want to keep these right in that same section where you have all of your definitions, because again, this is where you're going to go when we start doing proofs for real. And we're going to do some pretty quickly here, coming up very shortly. So make sure you're getting these and keeping these all in the same place. So in this theorem, again, this may seem pretty obvious that if you have two angles that are right angles, then those two angles have to be congruent. So let's take a look at a proof here. So again, you're going to want to add that to your theorems and definitions section. And then we're going to do a proof. So I'm going to take you to my camera over here because I can write much better on a piece of paper. So here's the theorem in shorthand. So, math people, we don't really like to use a lot of words. If I wanted to use a lot of words, I would have been an English major. So we tend to use a lot of symbols for things. So that theorem really is going to shorten to this. So when we get to using this in a proof, so if I were you, I would have that full out definition written down just so that you can remember what it means. Because when it comes to the symbols, it's going to take some getting used to these symbols. But this theorem is really saying that all right angles are congruent to one another. So when we actually use this theorem in a proof, we're going to shorten it to this. But again, I would have that definition here. I would write down both of these. So I would have this definition here, but then write this down with it as well, so that, what is happening? Okay. So you'll want to have this definition written down, and then maybe next to it do have this. This is the shorthand version of that theorem. So for this theorem, if we look at the information that we're really given here. So basically this statement is, there's a hypothesis involved in this statement, right? There's a claim that someone's making, and then a conclusion that's being made. So the claim that's being made here is that if we've got two angles that we know are right angles, then the conclusion we could draw is that they are congruent. So really, in this case, the given piece of information is that we've got two angles that are congruent. So let's say we have, or two angles that are right angles, sorry. So let's say that we've got angle A is a right angle and angle B is a right angle. So I'm just making up those angle names. We're just saying we have two angles, they're both right angles. So I'm just saying, okay, let's call them angle A and angle B. So we know that they're right angles, and what we want to prove is that angle A is congruent to angle B. So that's the proof that we're after. So when you write your proof, you're going to start off with a statement that you know is true. So you're typically going to start off with a given. So our step one in our proof is going to be that angle A and angle B are right angles. So again, I'm going to use these symbols for right angle. And the reason for that, so I'm going to have my statements over here. So my statements are on the left-hand side. And the reason I'm going to put on the right-hand side. So the reason I can say that this is true is because it's given. I was told that it's true. And then in number two, if you think about back to yesterday, we talked about what it means for angles to be right angles. And an angle is a right angle if the measure of it, so the measure of angle A is 90 degrees, and the measure of angle B is also 90 degrees. And now we have to give a reason for that. And the reason for this is that all right angles are 90 degrees, right? That's kind of the definition of a right angle. And then for step 3, what we can say here is that, right, and then for step 3, I can say that angle A has to be congruent to angle B. And the reason here goes back to what we talked about yesterday. It's the definition of congruence, right? So we know that if two angles have the same measure, that means the angles are congruent. So two angles with equal measure are congruent. So this says here, we've got two angles, they have equal measures, right? We just said that. So make sure that when you say if you've got two angles with equal measure, that you've said that. And then we know by the definition of congruence that if they have the same measurement, then they are congruent. All right, so that was your first proof. Congratulations, feels pretty good. Maybe not. I hope you're not too overwhelmed right now. We'll definitely be practicing this. I just wanted to give you a sort of a brief introduction of what those look like. So we're going to do a couple more theorems today. We're not actually going to prove all of these just because it will take way too much time. And these the rest of these sort of fall into that same category of, it seems pretty obvious that they have to be true. But know that because they're theorems, if we needed to prove them, we could. All right, so this is our next theorem. This looks a lot like the last one, so you could imagine the proof would be very, very similar. So here we're saying, okay, if two angles are straight angles, then they have to be congruent. So really this is the same as the last one, except our given is that the angles are straight angles, which means that each of the angles are 180 degrees. And if both angles have the same measure, then they have to be congruent. And in this case, they do have the same measure because they're both 180 degrees. So I'm not going to write out the formal proof, but I hope you can kind of get the gist of what that would look like. And then for supplementary angles, so this one's a definition, but two angles, if two angles have measurements that add up to 180 degrees, then those angles are supplementary. So picture-wise, this is what it would look like. So quite often you'll see a picture like this. You've got this straight line that's 180 degrees, and then it's being divided up into two smaller angles. So we know that the measure of the x plus y would be 180 degrees. And then if you can have separate angles that are also supplementary, right? This angle, if this is 40 degrees and this is 140 degrees, they add up to 180 degrees. So angle B and angle A would be supplementary. So they don't have to be exactly, being formed by a straight line, but you can see where you could put these together to make them into a straight line. So if you're given that two angles are supplementary, that means that they add up to 180 degrees. So you may be able to maybe use that information to write an equation, for example. All right, so complementary angles, similar to supplementary angles, these are angles that add up to 90 degrees. So we have a 90-degree angle here, and we've divided it up into smaller angles, so these two angles would be complementary. And here we have two sort of separate angles, but they add up to 90 degrees as well, so these angles are also complementary. Keep in mind that when we talk about complementary or supplementary angles, we say that they add up to 90 degrees, not that they equal 90 degrees. So just be careful in your language there, because angle W and angle T do not equal 90 degrees, they add up to 90 degrees. All right, so here's a theorem that doesn't come up a ton, but it's definitely worth mentioning because it will come up sometimes. But again, this is why you want to have that section to refer back to. Some of these theorems we're going to use so much that you're just going to remember them. And then there's some that we're going to use less frequently, so you're going to want to have a list to refer back to. So in this case, if we have two angles that are supplementary to the same angle, those have to be congruent to one another. So here's a picture of what that might look like. So we've got two straight lines that intersect here. So we've got angle 1, angle 2, and angle 3. So I know that angle 1 is supplementary to angle 2, and I know that because if this is a straight line, that's 180 degrees, and these two combine to make that straight line. So that makes angle 1 supplementary to angle 2. And I also know that angle 3 is supplementary to angle 2. So now I have this angle that's supplementary to angle 2, and this angle that's supplementary to angle 2. And what that theorem that we just learned means is that if angle 1 and angle 3 are both supplementary to this same angle right here. So the conclusion that we could make here, so this is the information we know, and the conclusion I can draw from that then is that angle 1 is congruent to angle 3. So that's what that theorem is saying. Again, for time purposes, I'm not going to go through and prove that. But you're certainly welcome to try to prove it on your own if you want. And if you do that and you want to run it by me, I'm happy to check it over to see if it's correct. And this next theorem is very, very similar to the last one. So in this case, you have two angles that are both supplementary to other angles, but those other angles are congruent to one another. So let me show you in a picture what I'm talking about. Right, so here's a picture of that scenario, and this is just one scenario or one way that picture could look. So we've got angle 1 and angle 2 that are supplementary. We know that because they form that straight line. And angle 3 and angle 4 are supplementary. Again, they form this straight line. And in addition to that information, we also know that angle 2 and angle 4 are congruent to one another. So I know that this angle is congruent to this one, which is going to then force angle 1 to be congruent to angle 3. So that's the conclusion we're going to make. So this is the information that's being given, really. We've got two pairs of angles that are supplementary, and then these angles that they're supplementary to are also congruent. And the conclusion we can draw from that then is that angle 1 has to be congruent to angle 3. Okay, we're almost done. We've got two more, and they're very, very similar to the ones we just did, except that now we're going to talk about them with complementary angles instead of supplementary angles. So they would be the same kind of thing, except replace the straight lines with right angles instead. So we've got if two angles are complementary to the same angle, then they are congruent. And then lastly, we've got if two angles are complementary to congruent angles, then those two angles have to be congruent to one another. So again, this is very similar to the supplementary one. So if you go back to that supplementary angle picture and exchange out the straight lines with right angles instead. So if you would like a further explanation for that one, you can go ahead and come back on to class and we can talk about it some more. But that's it. Those are our definitions and theorems for this lesson.